All right, and it's 9 o'clock. Are we good to go? Nice. Welcome, everyone. Thank you so much for joining us here today. I hope that we get to learn something exciting and kind of get a sense for what is possible today with data. So what I'm going to talk about is a project that I've been working on for roughly the last year. I have been begging and begging and begging my management to buy me this for years. So this is a headset that reads EEG. And it's made by a company called Emotiv. It's not a Microsoft product. But I had an idea of how I could use it in conjunction with machine learning to do potentially some cool stuff. And so for my first, I have a whole bunch of ideas, but for my very first idea that I tried to implement, I took this headset and I put it on my husband and I asked him a series of questions. And first, I had him tell me the truth to all those questions. Then I had him lie to me.
That was easy, right?
Very easy. And what that gave me is a labeled data set of here's what your EEG looks like when you're telling the truth, here's what it looks like when you're lying, and that's very easy to feed into a machine learning algorithm to build a classifier to then perform lie detection. All right? So labeled data sets what we use. So that's what we're going to talk about today, is that process, kind of how I've refined the experiment, various things we've done. So here we go. Let's start with what exactly is EEG. I'm not even going to try to pronounce that for you. Are they medical people here? Who are the medical folks? Okay, thank you. Yep, there you go. But essentially what this is EEG is a very non-invasive way of reading your brain waves, the electrical chemical activity in the brain. And that's all that we're reading here. So I'm just getting a sense for that activity that's happening in your brain. Now, I think everyone in this room probably knows this, but just to be crystal clear, you can't really do mind reading with this, okay? If you put this headset on, I don't know what you're thinking. The only reason I'm saying this is that I have gotten questions. So let me just state up front, no, you can't actually do mind reading with this. But what I can do is I can create mappings between a pattern of EEG and an action, either in the physical world or in the virtual world. So there's examples of people like making a drone fly using the power of their mind, and we'll see that in just a second. And then I can also take patterns and use machine learning to learn using historical data. So, you know, your EEG looks like this in this situation, looks like that in other situations. With machine learning, you just need to give it a data set of historical data that's labeled, and then you can use that to do predictive analytics. So that's what the problem I was trying to solve was here. So before we get started and dive into all the details of that, though, let me give you a demo of just a little taste of what this headset can do. I'm going to jump over here, and this is a piece of software that actually comes with the headset. It's called the EPOC control panel. This headset is actually called I think the EPOC Plus headset. And so right now, all of those lights are green. This is reading 14 channels of data from various places in my brain. And right now, the green means that the signal strength is highest. So we have good, very high signal strength coming from each of those 14 channels. And I just want to show you one quick thing, which is this cognitive suite right here. And this is using something that is not actually machine learning. It is just basic pattern matching. But if any of you guys have studied machine learning, you might know that just very basic, very early artificial intelligence, pattern matching was a pretty effective way of simulating an AI. Is anyone familiar with the ELIZA project? ELIZA by Joseph Tannenbaum at MIT in the 1960s? Okay, ELIZA was kind of the first kind of being to pass the Turing test, where people actually believed they were talking to a human when it was in fact a machine. So ELIZA simulated a Rogerian psychotherapist, and that style of therapy is one in which you basically reply to every single thing that the person says with another question, because you're supposed to help them, figure it out and come to their conclusions themselves. So something like, oh, I hate my mother, or my mother's always doing this thing. Why do you hate your mother? She's always making me do something. Why is she always making you do this? And then it's, to help you kind of, sort through your thoughts. But it's actually pretty easy to implement, because you just basically need to flip around the question and re-ask. But people really believed that ELIZA was a real person and would pour out, all of their secrets to her. It was a very, very interesting thing. And that was just using pattern matching. And this, again, is just a simple example of pattern matching, but we can do some pretty amazing things with it. All right, so what I'm going to do is I'm going to train that little hovering cube to control it with my mind. All right? So the first thing I need to do in order to do that is I'm going to record a neutral brain state. So I am going to come here to this neutral state. I'm going to hit train. It's going to take 8 seconds, and I'm just going to try to really relax and go to a happy space. I'm actually going to close my eyes too, just to shut out distractions. So there's going to be an awkward 8-second pause, but we're all going to be okay with that, all right? And just yell when it, because my eyes will be closed, just yell when it's done, okay? All right, here we go. 8 seconds, just relaxing my mind so it gets a baseline of what my mind looks like. Here we go. Done. Thank you. All right, accept the training. Yes. All right, so we have kind of the neutral state. Now what I'm going to do is there's a series of actions you can do to that particular cube. And I'm going to do, I think, pull, because it's a nice thing. It comes towards you. It gets bigger. It's very visual. So let's do pull. And I'm going to train out. And now what I'm going to be doing during that 8 seconds is thinking, pull, pull, you know, as hard as I can with this cube and just have that thought. And of course, I don't actually need to be thinking pull. I could be thinking hamster or whatever random thing. But as long as I consistently think that when I want the cube to pull towards me, it should work, right? So here we go. I'm going to train this. We're going to have 8 seconds, and I'm going to picture in my mind that cube coming towards me. And here we go. All right. So once I accept this training, the cube will be live. And then at that point, I'm going to kind of rethink what I was thinking to make that cube. I'm going to be thinking pull to try to make that, that cube move towards me in my mind. So here we go. I'm going to hit yes. I'm relaxed. And now pull. Come on, right? If that doesn't deserve applause, I don't know what does. Let's do it again. Isn't that awesome? Oh my gosh. I feel like Jean Grey up here. I don't know what you guys are thinking, but I thought that was pretty cool. So you can see why I really, really wanted this headset. You can just do some amazing things. So we got this headset, or I got this headset, and I started thinking, you know, what are some cool things I could do with this? And my master's degree was in machine learning. It's been a passion of mine for a long time. And I was really excited about different applications of using EEG in conjunction with machine learning. And I started thinking about, for some reason, lie detection. I don't know if I was watching CSI or what exactly sparked this, but I did actually take, I'm by no means a neuroscientist, but I took like 1 or 2 classes on the brain just as part of the artificial intelligence I was studying in college. And one of the things that I remember is that when you're telling the truth, that typically activates the recall centers in your brain, right? And when you're lying, that typically activates the creative centers in your brain. So I started thinking, since it's measuring these 14 different places on my brain, would it be possible to differentiate between lying and telling the truth with something like this? And then it's also kind of an interesting problem because when you look at kind of the state of the industry today, polygraphs, typical polygraphs, lie detectors, are not very accurate. There's a lot of people that are kind of very anti-polygraphs and using them for government, to tell if somebody's really lying or that sort of thing. Because critics argue that they're measuring emotion, not so much whether you're telling the truth or lying, but just how agitated you are about it. And if you're really worried or really nervous, sometimes that could potentially predict something. But it measures things like heart rate, the conductance, like the galvanic skin response, your sweat, your eyes, emotions, rate of breathing, all kinds of things like that. So my goal with this experiment, or when I kind of started out here, I was like, okay, I wonder if I can use EEG data to predict if someone is lying. So that was the goal. And I listed out the tools that I used in good little former grad student fashion. Here's my stuff. So the headset, the test bench software, which I can show you in a sec if you want to see it, and then Excel, and then I was using Azure Machine Learning, and we'll talk a little bit about that as well. All right, so here was my original experiment procedure, and I've actually refined it since then. But originally what I did was I had my husband sit in a chair. I had him sit kind of relaxed and with his eyes closed. And one of the reasons for that, I didn't show you one of the other demos, but facial movement is actually picked up in the EEG waves. So if I make all kinds of crazy faces, like moving my skin a lot, it will actually show up in the EEG, in the waves that we see. I ran a tool called Emotiv Test Bench. It's another thing that came with the software. And what it does is record all of those waving. So it's basically waves coming off of your brain that look like that for each of the 14 channels. So there's kind of 14 waveforms moving all over the place when you can visualize. And then I asked him a question. And when I asked the question, I made sure to mark. So I annotated the data using the Test Bench software to say, okay, here's when I started asking the question, or here's exactly where he was answering the question. So when I finished saying the question and he was responding, I would hit a 1, so I could zero in on just that data out of all the time series, kind of zero in on when he was actually telling the truth or lying. And then I asked the list of questions multiple times. EEG is very, very noisy data. And so the recommendation was to ask to do run trials, multiple times and take averages. So that's what I did. So then I had him reply to each question with a yes or no. I tried to make them all very clear-cut yes or no questions. I did have him close his eyes to minimize that facial movement so that I wouldn't get extra noise in the data there. And then I did it once for truth and had him answer all of these things truthfully. And then I did it once for lies and had him lie to all of these questions as well. So then I had those labeled data sets. And some of just in case you're wondering, those were the original questions that I asked. Some of them, the correct answer is yes. Some of them, the correct answer is no, because I wanted a nice confusion matrix of, true versus false and yes versus no, get nice distribution between all of those. So we do not have 5 children, at least I don't have 5 children with him. Hopefully he doesn't have 5 children that I know of. So some of these are yes. He does have a PhD. We do not have a dog. He does not have red hair. So there's a nice kind of mix of both. Okay. And then here is, do you guys want to see Test Bench real quick? Would that be interesting or not really? I'm seeing yes. Let me just pull that up super quick just so you can see what that looks like. So this was the process of annotating the data. Let's see how speedy my machine is going to be. All right, so this is what Test Bench actually looks like. So you can see those 14 channels of data running across, and then what I would do, and then you could actually turn them off. There's a little checkbox so you can just focus on a couple sensors if you so choose. And then there's actually markers here, so this is how I can annotate. So I have send manually. So basically, I won't open up mine, but I had various different markers that finished asking the question, value 1, send, and then that would show up in the data. And then the data, what that actually would look like, so it was doing this, it could annotate, and I think if you send a data, so let me just put a junk one in there. Hello, value of 1, and then send, and what you see is a little 1 here on the bottom, but then in the time series data, so essentially this dumps into a proprietary format, but then they have a convert to CSV, so then you can get it in CSV and open it in Excel. And if you take a look at that, I can show you that real quick as well. Boop. Here's a quick look at one of the data files. I don't remember who user 15 is anymore, which is good. Okay, so this is, there's a counter. So this is all the stuff that just comes with the software, and then I added some label columns at the end. But the counter just counts up. So it takes readings 128 times a second. And so this just actually counts up to 128 and then resets. So the counter is not that useful in terms of machine learning. That's not that useful. These are the actual 14 channels of data right here in different locations. So you see crazy things like AF3, F7, F3. I'm going to show you a chart in a second that shows you where each of those map to different places in your brain. There's also a gyroscope in there, so that actually might be interesting. If any of you guys have ever watched the World Series of Poker, and you know how sometimes people have tells, they might tilt their head a little, there might actually be some signal in there. I haven't played with that column so much, but I kind of want to look at those. This is the marker column, so when I did that annotation of data, I could put ones, by default there's 0, and then a 1 would appear where I had put a marker. So I could use that to zero in specifically in the data appropriately. And then timestamp, they have it in kind of an inconvenient format where they give you the seconds and then the milliseconds in a separate column. And so I actually combine them later just to make the math easier. And then these are the contact qualities of each of the sensors. You saw how it was green right now. Green actually correlates to 4. And you can see most of the data. This is kind of what I'm getting the headset on. And now it's all 4. So that means an all green reading. So everything is a strong signal strength where it's reading well from those nodes. And then these are the ones I added manually on the end. This is my label column. If you're familiar with machine learning, you know, we use a bunch of variables to predict another variable. And so I was trying to predict truth or lie. And this is my is truth or is lie column. This is the time column. As I said, they have the seconds and milliseconds in separate columns. So I just did a little math, you know, milliseconds times 1,000, seconds times 1,000 plus milliseconds to give me this all is the time as one number. And then I have a user ID that I added later. This was after I expanded beyond just my husband and I was working with other people as well. All right, so that's what my data looks like. Now let me jump back to here. You saw kind of the process. You saw what questions were asked. Here's a quick just visual. I know it can be sometimes hard to see this if you're in the back of the room and such, so here's a quick visual of what the headset actually looks like, and you can see those channels and kind of where they rest. And this is my poor husband. I made him pose for pictures to like put on my blog and things like that, or to document the research. And you can tell he's really happy about helping here. No, Jennifer, I don't have an Ashley Madison account. Can I please go watch TV now? No, honey, you can't. All right, sensor quality. So this was what I was talking about before. You saw that for the 14 channels of data, each of them had that contact quality column. And so this helps determine how well it's reading data. So again, they're all green, so most of the time they're all 4. But when I was still getting a hold of the headset at the beginning, I had trouble getting them all green. So I took a couple screenshots of here's some early looks. Yellow is 3, orange is 2, red is 1. So it's just a scale of progressive degradation of signal quality. All right, and all of that is captured in the data, which is really nice if you want to do data cleaning around things like that. You can throw out data where you're not getting good readings from all places on the scalp. All right, here are the sensor positions. You saw some of those column names when I opened the Excel document real quick. And so this is where they actually map to the different places on your brain. The way you look at this is it's a top-down view, and this is the nose, like that top little mound is the nose. So the T7 and T8 are the ones above your ears. The O1 and O2 are the ones in the back of my head right here, these guys, which are pretty uncomfortable. All right, there we go. Now, another thing I wanted to do is I don't actually believe that I'm the first person to have thought of this. So I also, in good little grad student fashion, went out to research and see what are other people doing in this field. Has anyone else tried to do lie detection in conjunction with EEG? So one of the things I found is that there are some government agencies actually experimenting with this. And but what they're doing is a very different way. Instead of asking yes or no questions, they actually use a very visual mechanism. And that is because of a phenomenon known as the P300 ERP. ERP stands for event-related potential. And what that is it's an actual dip that you see in the waveform. So if you look at this little graph right here, oops, sorry, you can't see it. See that little dip? That's the P3 in the left-hand graph. So that is something that your brain does instinctively when you recognize someone. So if you're walking through the crowd here at the conference today and there's a face that you're just oh, I know that from somewhere. You know how you get that little flash that, oh, I know that person. That's just an instinctive thing that your brain does when it recognizes something. And so that's what this measures. And they call it the P300 because it's activated approximately 300 milliseconds after you see the stimuli. So imagine you can see kind of the graph right there. It's kind of around 250 all the way to 400, but approximately 300 milliseconds. And so how these people are using this data is by taking by showing visual images. So imagine I'm trying to interrogate someone about a crime and I show them a bunch of pictures, and maybe some of them are just neutral, random pictures of whatever, but then I have a picture of the crime scene in there somewhere, or I have a picture of the murder weapon, or things like that. In that situation, if their brain is instinctively going to recognize that, you can't fight that kind of instinct. And so there's kind of some lines that tell you kind of what's obvious. If they recognize things that only only someone who committed the crime or who had intimate knowledge of the crime at least would know, then that may indicate guilt, or maybe a good thing that they know more than they're telling. All right? So kind of cool research. It's a little different than what I was trying to do because I'm still asking the yes/no questions. But what's neat here is it gave me a good sense of things like timing, how long it was taking like one of the concerns I had was this thing was taking data readings, I said 128 times per second. If you do the math, that's approximately every 8 milliseconds. And I wasn't sure if that was enough, what's the buffer, how fast do these things happen? And then the fact that, instinctive reactions like this were happening in the hundreds of milliseconds made me think, okay, 8 milliseconds is good. I'm good here. So that was another good thing that kind of came out of looking at this, researching this. All right, so now let's transition for a second. I kind of set up, here's my experiment and what I was doing. Now let me tell you just a teeny bit about Azure Machine Learning. So the tool I chose to use, I do have a machine learning background, and I think Azure ML is an extremely cool tool. If you haven't looked at it yet, it contains 25 different machine learning algorithms for supervised and unsupervised learning. We have a k-means clustering algorithm if you want to do unsupervised. What I'm trying to do is predictions, which is essentially supervised learning. And there's all of these modules that are available for importing data and cleaning data and doing those kinds of things. So you can, import data in there, do all kinds of nice data cleaning, throw out bad values or throw out values where my signal strength wasn't good enough, or those sort of things. A lot of good stuff available there that a data scientist would use normally. And then you can create experiments using a very simple drag and drop model where I take data modules, like these data cleaning modules, and just like wire out my data flow. It's very, very simple and nice and visual. And then when you're done, essentially it's a button press to say deploy this, and then it gets exposed via a web service, and then you can make REST calls to it. And by default, it gives you 3 different languages to call. It gives you all the code in 3 different languages. So C#, R, and Python. It gives you code that you can just run, and that will call the web service, and you're done. Everything else gives you amazing documentation of all the REST calls and such, so you can write it in whatever other language you want to, because every language has a REST library, right? So there you go. So that's a little bit about Azure Machine Learning. So how one kind of template for setting up a model like this to do supervised learning to make predictions is that you can drag and drop a data set. So grab a data set from somewhere. And Azure Machine Learning does support pulling stuff from over the internet, like you can pull stuff from Azure Blob Storage or Azure Table Storage or elsewhere in Azure. You can pull stuff using a generic OData feed from like anywhere. You can use HTTP to pull stuff over. So there's a lot of different ways. Or you can just upload a local CSV as well to get data in. So a lot of different ways to get data into Azure ML. Then there's a lot of different data cleaning modules. There's various ones you can use. I did some like metadata editing and stuff. I'll show you my data cleaning process in a second. And then we split the data. Now, why do we do this in machine learning? In case you don't have a background in machine learning, the reason we do this is with supervised learning, essentially we're learning from historical data. We're learning from past data, right? And so we have all of these features or things that will influence, whether or not he's lying. And then we have our label, which is, lie or truth. Is he telling the truth or is he lying? So with that data, then we need to basically give it all that data to have it learn the correlations. All machine learning algorithms do is different types depending on whether you're using a decision tree versus a neural net versus a linear regression, those sort of things. But it uses some different kind of crazy beautiful math to find the correlations between those features and that label. All right, that's all that's happening with machine learning, supervised machine learning algorithms. And the kind of crazy beautiful math is different based on what algorithm you're using. So the reason we need to split our data set is because we want to also test how well our model performs. Because if it can do well on past data, okay, fine, but that's in the past. What we really want to know is how well can it do on new data that it's never seen before, so that we can use it to make predictions. So typically what's done is you hold back some of the data, and that's your test data. So industry standard is, usually you split the data 70-30 or 80-20 or something around there. And then I take the majority of the data, like perhaps 70% of my training data, and use that to build a model. So I'll use 70% of my data right here as my training data, and then I use some algorithm to determine what kind of math to find those correlations, and then I train a model based on that. And that model learns, okay, based on this EEG and these other features, here's whether he's telling the truth or lying. Then what we can do is take that trained model that's flowing into the score model, and then take that 30% of data that we held back and send in just the inputs, essentially just the features. All right, so for this EEG pattern, is he telling the truth or lying? And then we get a response back, but because this is some of our test data that we held back, we have the known right answer, right? It's a labeled data set, so we have the right answer. So then we can compare how it did versus how our model did, okay? So we pass in that data, see what it does and how well it performs against what reality is. Does that make sense? Okay. Then we score the model, that actually gives us a score for how well it's performing, and then I can do the whole thing all over again with a different algorithm, or the same algorithm with different initial parameters, because it does require some tweaking. There is some art to data science. So I do that kind of thing, and then I can do another model in here, and then evaluate model lets you compare two different models side by side and see how well they perform against each other. All right, so let me show you that in 1 second. But before I do, the one part I kind of glossed over here is the algorithms. So if you don't have a machine learning background, and you may be like, oh my goodness, okay, that kind of makes sense to me, Jen, but how do I know which of those 25 algorithms that you mentioned to use? Enter the Azure Machine Learning Algorithm Cheat Sheet. This is an amazing resource that the Azure ML team put together. And what it does is essentially gives you kind of a decision point on, what am I trying to do with this data? I'm going to give you a link to download a nice high-res copy of it too, just for all the people with cameras up. I will give you a nice link to this. But essentially, you can kind of look and see what exactly you want to do with your data, and then be able to make sense. So we start at this little start node right here, and then do you want to discover structure? So like cluster things together and kind of figure out what data I have available? Great, k-means clustering is a great way to do that. If you want to find unusual data points, you can use one of our anomaly detection algorithms. That's great for things like credit card fraud detection, right? Where you might have a data set where there's a whole bunch of, here's, valid transactions, and then a very, very small subset that's actually, known fraudulent transactions. And when your data is like that unbalanced, it can be really hard to train a model on it just because you don't have enough data on one side. So anomaly detection works really well there, where you can basically tell it, this data is all normal. Now help me find stuff that's not normal. So good there. It's also good for we used it for this project to monitor pipeline flow, like the flow of water, and when things were starting to get, like the pressure was getting too high and things like that. It was very interesting for that as well. And then the other things I might want to do are predictions, and that's using that supervised learning. And so there's two different things here, predicting values versus predicting categories. Now, what we mean by values are like values on a continuum, right? So like numbers, all right? So when you want to predict values, like let's say I want to predict based on square footage and zip code of a home and number of bedrooms, number of bathrooms, I want to predict how much the house will sell for, something like that. That would be a regression problem because I am predicting a number or a value. Then we also have categories. So categories are not numbers, but instead discrete buckets. So I'm trying to predict truth or lie. Will this person be readmitted to a hospital within 30 days? Yes or no? Will the University of Michigan fall out of the March Madness bracket in the very first round? Win or lose? Like those kind of things are what we look at for classification. So classification is predicting between two discrete categories or two discrete buckets. Regression is predicting a number. Make sense? Good? Good. All right, so I go here, what I want to do, so with the truth-lie problem, I want to predict a category here. And do I have 3 or more options, or do I have 2 options? 2, he's either telling the truth or he's lying. So I go down here to 2-class classification, and then it gives you really nice information about, okay, here's what each of these algorithms are good at. SVMs, or support vector machines, are really good if you have a really, really large number of features. Decision trees are great if you have nonlinear data. The boosted decision trees are good, but they have a very large memory footprint. These train really fast. These are highly accurate, like these kind of things. So it gives you kind of, in a declarative fashion, here's what each one of these are good at. And I also just did a Channel 9 video on kind of pros and cons of each algorithm, which I have not published yet because I literally just recorded it like 2 days ago, and I still need to do some video editing and stuff, but that will be coming out on Channel 9 within the next couple weeks. All right, so if you do want to download this yourself, you can go to aka.ms/Azure Machine Learning Cheat Sheet. and that will give you your own copy in nice PDF format. And then I also wrote a blog post on getting started with Azure Machine Learning. This was actually written for a student audience, so it's actually titled, How to Win a Hackathon with Azure ML. So just kind of ignore the spin in the first paragraph, and then really the rest of the blog post is a getting started with Azure Machine Learning blog post. But it gives you a lot of cool things. It gives you some really cool data sources to play around with. If you're like, ooh, I'd love to just kind of experiment with machine learning, but I don't know where to get cool data sources. I give you some cool data sources. There's a tutorial. I have a link to a tutorial that's a nice kind of step-by-step everything from getting started where you're how do I get data into Azure Machine Learning, to building and training a model, to publishing it and calling the web service, like the whole end-to-end thing. So feel free to check that out as well if you'd like. All right. So now I think we are ready to see what I did. So I took this data and I actually put it in Azure Machine Learning. So let me show you that really quickly, what that looks like. So here is the model that I created. And what I'm doing here at the very top, I can zoom in on this a little if you actually want to be able to see it. But what I'm doing here in these sections, so let me actually caveat this. So before I show you this, so this is not actually doing lie detection. This was a really, really early sample I did where I'm like, can I even differentiate between the lie session and the truth session? Like, is that even possible? Very, very early kind of look at this. And so that's all I'm doing here is just trying to differentiate between those two sessions, the lie session and the truth session. And they were done back to back, right? So I asked him all the truth and then I asked him all the lie. So his mental state shouldn't have changed that much between those two sessions because they were one after the other. But this is essentially what I'm trying to do is I didn't do crazy time series processing in there. I'm just like, can I differentiate between the truth and the lie? So what I did was take those the data. So I took my Excel that contained the lie data and the one that had the truth data, merged them together here in this add rows, and then I'm using a metadata editor here to add to say that my is truth column is my label column. So that's what I'm labeling here. I'm dropping some of the columns here because you saw there was a whole bunch of extra stuff, like the thing that counted to 128 and then like reset itself, like that was not useful. So I threw out some of that extraneous data that I knew was not going to be relevant. And then I just did a simple split. So let's split my data into training and test. And I tried two different algorithms to start with. One of them was a logistic regression, which is a linear algorithm, or works well with linear data. And then I also have a decision jungle, which is an ensemble of decision trees working together. And if I look at what we see here, so with the evaluate model, you can actually visualize, right-click and visualize it. And you can see, so let me tell you how to interpret this first graph. So what this first graph is charting is the true positive rate versus the false positive rate, okay? So the true positive versus the false positives. We have true positive right there, false positive right there. So this kind of, the diagonal line through the middle, that's essentially 50-50 random chance, right? Monkeys flipping a coin kind of deal. So you want your algorithm to perform better than this line. If it's not performing better than this line, then start over. Something's wrong. And you can see right here, this blue one, this one was the logistic regression. That one did okay. If I look down here at the accuracy numbers, it was maybe 71% accurate. So yeah, okay, there's something there, but which may mean that this data just isn't very linear. But if you take a look at the decision jungle, so a perfect score would be if it went all the way up to this top and then all the way across right here. And if you get a perfect score, that usually means something is wrong too, because real life data is messy, right? 100% accuracy with the ML algorithm is really not doable. Even 90s, high 90s, you start to question, am I doing something wrong here? But but you can see in this first thing that I was running, if you look at these numbers, so I give you nice numbers right here. So true positives, false negatives, all of those things. So you want your true positives and your true negatives to be large, and you can see they are. You want your false positives and your false negatives to be low, and they are right here. And then you can see this, the decision jungle gave me an accuracy of 93%, which is pretty good, as well as a 94% recall and 91% precision. And then there's an F1 score, which is essentially a combination of precision and recall. And then this area under the curve number, AUC, is 98%, which kind of takes everything into account together. And then there's kind of a distribution of the various bins like over the range of data. So you can see you get a lot of really cool stuff here, and the ability to kind of iterate on these models, see which ones are performing well, change the algorithms out. It's super easy by just dragging and dropping in a different algorithm. I can change what algorithm it uses and see how well does that one perform. So it does make it very, very simple and fast to almost like a rapid prototyping for machine learning, which is really nice. All right, so that's a quick look at that particular demo. Now, here's some of the modifications I made for my second data run. I don't actually expect you to read this at all, so let me just call out some of the interesting things here. Number one, I used multiple markers. Instead of just having the one marker when I finished saying the question, he was about to give the answer, I have a marker from the beginning of the time I start asking the question to the end of what he just responds. So I have that whole chunk because, I think you start thinking about the answer as the person is still talking and such. So I wanted to kind of capture that whole thing and do some interesting work with that. I'm taking a neutral brain state recording. Remember when I was training to pull the cube with my mind, I needed to provide that neutral brain state. So their algorithm is obviously using that. And the more I think about it, I think just to normalize the data well, having a neutral brain state, because my brain might spike at 8, and Mark Racinovich's brain might spike at 24. So we just don't know. So the neutral thing might help with data normalization to have it work well across all users. I added more questions. My initial question list was a little short, so I added a few more, and I still made them all kind of yes, no, hopefully very obvious, or questions with a clear-cut answer where they weren't too ambiguous. I also switched the order. I started thinking about fatigue effect. So if you wanted to be one of my volunteers and I came and put this headset on you and I started asking you all these questions and having you tell the truth and then lie, it's kind of fun at the beginning because you're like, oh, this is kind of cool. And then by the end, you're like, oh my gosh, would this woman stop prattling off things to me, right? Your interest level kind of wanes. And so by asking some people to tell the truth first and asking other people to lie first, I'm hoping to reduce that fatigue effect, right? If I asked everybody the truth first and then everybody lie first, we might have seen that consistently across people, but I flip-flopped it so some people lie first and then other people tell the truth first to hopefully normalize that out. The next thing, I am collecting additional data about the test subject. Just a couple of quick demographic things. I am asking male versus female. I'm also asking whether they're right or left-handed. Somebody suggested including that as a feature. Have you ever heard the work that, or the thing that what hand you use correlates to the dominant side of your brain? I don't actually know if that's true or not, but I thought that would be interesting to at least put it in as a feature and see if the algorithm finds it relevant. So whether someone's using right-handed or uses their right hand or left hand as their dominant side. So decided to collect that data as well. I don't have to use it, but at least that way I have it if I need it. And then I also am now mixing truth and lies in a single session. So one of the things is that even if this was a highly effective thing, if I was collecting all the truth in one session and then the lie in another one, you need to kind of tease out those confounding factors, right? Is it that they're in a certain mental state those time, or is it that they're really telling the truth versus lying? So by mixing them in the same, when they're in the same mental state, so having them, all right, tell me the truth, then lie, then truth, then lie, all kind of mixed together, that might help tease that out. All right, now I kind of tell you how I'm trying to kind of expand this work beyond just my husband. I'm trying to get data from a lot of different people to see if I can build something that would normalize across all people. And I don't know if I can do it, but some of this early stuff seems kind of promising, and so I'm having a lot of fun trying. So we'll see how far we can take it. So right after I'd done kind of this initial work on my husband, I work on a distributed team. I actually live in Michigan, and my manager lives in Minneapolis, and we're kind of spread out all over the country. And we had a team offsite where we all got together in, I think, Arizona or somewhere. And I had some time with my manager, or I had some time with my team. And there was a camera floating around because we all do Channel 9 videos and stuff. And so I grabbed the cameraman, and my manager's like, hey, can I do something? Would you mind can I take your data for this study I'm doing? And he's like, yeah, sure, whatever. So anyway, I put the headset on my manager to try to do the same type of process. And first, I had him tell me the truth. Are you a female?
No.
Are you a male?
Yes.
Have you ever worked for Microsoft?
Yes.
All right, you get the idea, right? Okay, then I had him lie to me. I asked him to lie. I still can't believe he agreed to do all this on camera. So. Do you have a PhD?
Yes.
Do you currently have a pet?
Yes.
Do you have blue eyes?
Yes.
All right, guys. What would you do if you had access to your manager's brainwaves? Let's go. Do you believe Microsoft is the best company in the world to work for?
Yes.
Am I going to get a promotion this year?
Yes.
Okay, so we all saw that totally awkward little giggle, right? Oh my gosh. All right, so of course I did what any logical girl would do, and I ran all of his EEG data into its own machine learning classifier, and here's what we did. Oops, let me do this. Oh, come on now, PowerPoint. There we go. All right, and I built, so what I did was I that night, I went back to my hotel room. I uploaded all his data, truth, lie, built a classifier, and to see what would happen. And then I wrote a really horribly designed, really ugly Windows 10 app to have a front end. I'm sorry, design is not my strong suit, so I threw some controls on a page. But just to refresh you, what were the questions I asked? Do you believe Microsoft is the best company in the world to work for? My manager said yes. My classifier says, oh, look at that. He just got an iPhone. I'm just saying, who knows? He's really into design. And the next one, the question that really matters, am I getting a promotion this year? Drum roll, and oh, yes, I am getting a promotion. Wonderful, wonderful, wonderful. So I'll let you guys know in June if that works out or not. I don't actually know. And I will have you know also, does anyone watch Mythbusters here? So when I was envisioning this in my head, I was totally thinking of like the Mythbusters, like confirmed or denied. So I did a quick internet search and I did find a Mythbusters font. And so that is the Mythbusters font right there. So I'll just have you know, I love the internet. They just have everything. It's wonderful. So Mythbusters font. Here you go, John. All right. So we saw all of that. We just called an Azure Machine Learning web service. Let's start there. All right. So what I was doing, what that Windows 10 code was doing was calling out to that web service. So I created a classifier. I exposed it via REST, which is essentially a button click in Azure ML. And then it was making calls to it from this Windows 10 application. And then it gave me back the results. I just called it in, you can actually call it in two modes. You can call it in batch mode by sending a whole bunch of data and then getting a whole bunch of responses, or you can send like a single kind of request response thing as well. All right, so that's a quick look at that. Now the next steps for this work, as I said, I kind of started with my husband and then did my manager. And what I've been doing now is trying to collect data from a lot of different people just to get a large enough data set to really be effective across people and be able to see if I can generically predict people's lies. It seems to work with fairly high accuracy if you if I have training data in there on the person. But with new people, if I don't have already training data in there, it's not. So I think I need to work on the data normalization of EEG across people. So that's kind of some of the next areas I'm looking at. And I'm looking at different algorithms as well. This is very much akin to kind of like a speech recognition type problem, because you have all these waves, which are a lot like when people are talking, what the waves look like, and trying to confirm those, and it's time series as well. So a lot of it is, it's a tough problem to solve, but it's been really fun just kind of playing with it and seeing. I think it also kind of corresponds to deep learning. It's a good problem for deep learning as well. So I'm looking at some of those toolkits and trying out different things. So it's a lot of fun experimentation and a work in progress. So I'm working on all those things, experimenting with different features and how to extract different things from those waveforms. And then the other thing, and this one I don't think is that hard, is just implementing a real-time feedback loop. So essentially right now I build the classifier and then I do the test. I don't have it set up that you can just have the headset on the person and then in real time make the calls, but that's not that hard to do. The hardest part is just getting the data off of here and then converting into CSV in an automated process and then just calling a web service. So that I think I can throw together as soon as I can get like a block of time, I think I could sit down and crank that out pretty fast. All right. I do want to say thank you. After I kind of did the initial couple things with this experiment, I showed it to some of the folks in the Azure Machine Learning team, and they all kind of have been awesome. Like, oh, cool, try this, can we help you? Like, this is kind of neat stuff. So I want to say thank you to all the people who have reached out and helped with experimentation and are working with me to try to take this to the next level as well. All right, so in summary, this headset is amazing. It's so much fun, and I have a bunch of ideas for other machine learning related things I want to do with EEG as well. Azure Machine Learning is really an amazing tool. Like, it makes it very easy for data scientists and people with a machine learning background to use it. But also, if you don't have a machine learning background, if you're just a good developer, you can take that, you can use resources like the Azure Machine Learning cheat sheet, you can kind of learn some of these basics and be pretty powerful. So they do make it very, very easy to get started and develop a predictive modeling, even if you don't have a machine learning background. All right, and then husbands and managers beware. Mind control is next. Thank you guys so much. I have a minute or two for questions if anyone has any. Yes, sir.
Actually, it's a security question. So I noticed it's using version 1 of Azure portal.
Yes.
When you upload the data, how do you secure it?
Good question. So this particular, so I'm sorry, the question was about security. When you upload the data to the portal, how do you secure it? And so there's a lot of different ways to get data into Azure Machine Learning. One of them is, so what I was doing was just uploading a CSV. So in this particular thing, I was just uploading it from my local machine right into Azure ML. And there's going to be some discussions coming up next week at Build around security advancements on Azure all up.
Okay, so because in the version 2 portal, there's resource groups. I'm just saying, like, for a big company to start doing machine learning, like, you have to have a level of trust in version 1 portal to just dump data sets in there because other people will have access to them as well, just automatically.
No one.
Is this your own
Yeah.
subscription?
No, this is my own subscription. No one else has access to it.
Practice just to have your own subscription versus having like a company-wide subscription?
It depends on, so the question is it a best practice to have your own subscription versus having a company-wide subscription? That really depends on what you're trying to do. I have my own subscription, so all that data is secured just to me, but that's what it makes sense for because I'm doing this as a project for myself. It's not something that really needs to be shared with all of Microsoft. If you do want to, if you're working on something as a team, then yes, that would change. Like what you're trying to do would change. In that case, there's different ways to do that. You could certainly have. I know some people in kind of using the old version in the old things. There were ways to. You could create one common email and then everybody uses that one subscription. But yes, in this, that's kind of a very different scenario. Like this is just secured and locked down just to me. And then within Azure ML, you can actually give invitations to people to have them join your workspace, and that security is done at the workspace level.
There is security at the workspace?
Yep. So it's locked down just to me within my subscription, and then you can issue invites. Like one of the things, because I just had this locked down just to me, and then like when some of the folks on the data science team for Azure Machine Learning were interested, I invited them into the workspace, so then they had the ability to see and access the data, but yeah, nobody else does. Yeah, workspace level. Great question. I think in the back had a question first, and then you, sir?
Yeah, so yesterday in the keynote they demoed the Excel machine learning plugin. It looked like it somehow took a local data set from Excel, kind of shipped that off to machine learning.
Mm-hmm.
Turn this predictive sort of trend line. So
Yeah.
described it? Is that
So I haven't, I actually missed the keynote yesterday morning, so I apologize that I don't know exactly what you're talking about. But what I assume, or what I guess from the context, and I hope that I'm not saying this wrong, but yes, with Azure ML, there is a way to upload a local data set. So I'm here within my workspace here, and I can go to new data set, and then from local file, you just upload one. So then I can go here, navigate here to my data files in my Emotiv directory where I'm collecting all this data, select something, and then upload it right there. So I assume that what you saw is an API version of this functionality. Is that, did anyone who see that confirm or deny?
Computing the web service through Excel on the database.
Oh, okay, yes, all right, I can show you that too. All right, so that is this isn't uploading data, this is when you're calling the web service. Yep, let me show you that. So that's also pretty easy to do. I think I actually have a version of this saved locally. Let me go to my downloads. Downloads. Here we go. And let's search for Titanic. Okay, so this is one. I have no idea if this is going to work or this web service is still up right now, so forgive me if this demo fails. But essentially what you can do is after you've exposed something as a web service, it gives you this really nice thing that says, do you want to download an Excel version of this? And that's amazing for business analysts because if you don't want to write code to actually call these, it gives you out of the box an Excel spreadsheet that's already wired up to call this. So when I initially downloaded this just had all zeros right here, but this is another experiment I did to predict whether someone would survive or die on the Titanic. The ship that sank. So using data like their name, the class of ticket they had, whether they were male or female, their age, all of that kind of data I have access to, and then based on that and looking at all the things, you can figure out if they died or survived. And so what you can do here is just pass in different things. And I don't know if this is, so this one I had actually gone in and added a random passenger ID, and then I did, Jack Dawson, who was male and whatever, and then it did predict that he would die. So I can see if this is still active. I'm not sure if it is or not. But if I do passenger 1002 and survived, we can clear that or leave it 0. Yeah. And then let's take a first class passenger and call her Rose. I forget Rose's last name in the Titanic movie. And she is female, and she was like 21-ish. And she had 0 siblings or spouses, and she had 1 parent on board, and she had some ticket number, and then the fare was, I don't think this web service is still running because look, it's not updating anything over here. So I don't think it's running, but yes, what it does is you can do it in real time. It will call the web service. It's using the access key that's available from right here, and then it actually calls it. So yes, it's crazy easy to do with Azure Machine Learning. If you want to, I can show you exactly how you do it. But essentially, after you deploy a web service, you just hit deploy web service, and then it makes it available. Yeah. Yes, sir.
So the data is being recorded like every few milliseconds. It's a
Yes.
lot of data that you can't just at a single point to get a prediction from. So how did you determine what that period was?
Great.
How does the machine learning look at that group of data? So they get the Titanic.
Yeah, Titanic is easy. Yeah. Yeah.
Here's the result.
Yeah.
You actually have a moving kind of
Yeah.
flow of seconds between when the question was asked, some of them longer than shorter. How did you actually get that
Great.
data aggregated or grouped in such a way that it could actually look at that data as a whole?
Yeah, great question. So the question was around, the Titanic is very easy because you basically send a set of easy features and get a response back. But this is a time, the EEG thing is a time series problem. So what that means is that we actually need to take data from a certain amount of time and then do something with it. And the answer is I've actually tried a lot of different things to best account for that. There's a lot of different ways you can deal with time series. I believe there is one time series module within Azure ML to help you do some of the time series processing. There is also a lot of things, so you can there's the ability to drag and drop custom little modules into Azure Machine Learning. So you can add a little bit of R code or a little bit of Python into Azure ML, which is really nice if you're using those things for other things. So what I did was I added some custom code. You can use R or Python to do that, and I use that to aggregate the data. And I've tried a couple different things. I've tried basically just taking X amount of time on either side of, like, that was what I did initially when I just was recording one point. I just did a certain time window on either side of it. And subsequent things, when I was trying to, get greater accuracy there, I tried a couple different things. So you can do, you basically do some kind of aggregation on the waveform. So you can do things like looking at the min peak and the max peak and average across the peaks. So you can do all kinds of processing like that. Like, those are some things. And then there's this Pi EEG library that I found that kind of extracts features out of time series data. Like, you give it that, and it can find some things that it feels are interesting based on that data as well. So I was utilizing that as well. But yeah, I was doing all kinds of things that basically aggregated the data to send that as the point. That's a great question. Yeah. 10 points to Gryffindor. Any other questions? All right, thank you guys so much. Enjoy the rest of the conference.